Dear students, today we'll solve the CBSE Sample Paper 2023-24. Since the video will be very large, then I'll make these in different parts. So watch each part of the video twice and thrice so that you will be able to understand it very easily. If still you get any doubt at any stage or any point, then please don't hesitate to write in the comment box, or you can WhatsApp also in the WhatsApp numbers which are given in the video or in the description of the video. You can also send the email in the jugransir@gmail.com. I will try to solve all these problems so that you will get benefited and you will not stuck at any stage. आगे तक अगर आपने वीडियो को चैनल को सब्सक्राइब नहीं किया तो सब्सक्राइब कर लें सो दैट यू विल गेट द वीडियोस फोर्थकमिंग वीडियोस ऑटोमेटिकली. एक बात और है कि अगर इफ़ यू लाइक द वीडियोस सो प्लीज़ डोंट फॉरगेट टू लाइक एंड राइट द कमेंट्स. अपने साथियों के साथ ज़रूर इनको शेयर करें, क्योंकि हो सकता है जैसे आपको लाभ हो रहा है उनको भी लाभ मिल जाए, तो इसमें कोई हानि नहीं है. अपने साथियों को ज़रूर दें, क्या पता किसी और को भी फ़ायदा हो, तो इसलिए वीडियो को साझा करना ना भूलें. थैंक यू, ऑल द बेस्ट. सेक्शन ए, क्वेश्चन नंबर 1. Which of the following is not the property of an equilateral surface? A, they do not cross each other. B, the work done in carrying a charge from one point to another to an equilateral surface is 0. For a uniform electric field, they are concentric spheres, and D, they can be imaginary spheres. So here the answer is C. As far as the first option is concerned, they do not cross each other. This is the property that equipotential surface never intersect, because electric lines of force and equipotential surface are always perpendicular to the electric line of force. So if there are two electric lines of force, so there will be the two direction of the electric field, which is not possible. So two electric lines of force can never intersect. Similar is if the two lines are perpendicular to this, so again these two equipotential surface cannot be there. The second part is the work done in carrying a charge from one point to another to an equipotential surface is 0. So this work done is what? Q into delta V. As far as the equipotential surface is concerned, the name itself is very clear. Equipotential, that means every point has equal potential. So delta V will be 0. So therefore 0 into Q will be again 0. So second part is also correct, that the work done will be 0. And third is for uniform electric field, they are concentric spheres. So electric field is parallel like this. So equipotential surfaces will be perpendicular surfaces on these. They will be always 90 degree. So they cannot be spherical. Spherical may be only in the case of mono charge. So this way in concentric circles may be there, but this is not the case. So in this case it is not possible. So this is the not property of the equipotential surface. And D, they can be imaginary spheres. Yes, they can be imaginary spheres. This is this. So the correct answer is C. Now question number 2. An electric dipole placed in an electric field of intensity 2 into 10 to the power 5 Newton per Coulomb at an angle of 30 degree experiences a torque equal to 4 Newton meter. The charge on the dipole of dipole length 2 centimeter is A 7 microcoulomb, B 8 millicoulomb, C 2 millicoulomb, D 5 millicoulomb. Here we have electric field is equal to 2 into 10 to the power 5 Newton per Coulomb. The angle is 30 degree. Torque is 4 Newton meter. and the dipole length 2a equals to 2 centimeter, that's equal to 2 into 10 to the power minus 2 meter. So we know that torque equals to torque experienced by an electric dipole placed in a uniform electric field is P-E sin theta, where P is Q into 2A into E sin theta. Here 2A is the dipole length. Sometimes students get confused with the A. So this is not A, this is the 2A. So here substituting the value, we have to find Q. So this is 4 is equal to Q into 2 into 10 to the power minus 2 into E is 2 into 10 to the power 5 into sine 30. So this 2 into 2 will get cancelled. So 1 equals to Q into 10 to the power minus 2 and 5, that is 10 to the power 3, and sine 30 is half. So Q equals to 2 into 10 to the power minus 3, that means 2 millicoulomb. So the correct option is 2 millicoulomb, that is C. So C is the correct option. Third question, a metallic plate exposed to white light emits electrons. For which of the following colors of light the stopping potential will be the maximum? A. Blue, B. Yellow, C. Red, and D. Violet. So the correct answer is D. The violet. As we know, stopping potential V naught is related with kinetic energy, that is equal to half mv square, and this kinetic energy according to Einstein's equation, it is equal to h nu minus h nu naught. So this is constant, this work function fixed, only this factor will vary the value of this as well as the value of this. So this stopping potential is depending on the frequency. If frequency is more, then stopping potential is also more. So here frequency for the violet is greater than frequency for the blue, is greater than frequency of yellow, is greater than frequency of the red light. So here least is the frequency of the red and the most or the maximum value of the frequency is violet. So stopping potential for the violet is maximum. Fourth, when alpha particles are sent through a thin gold foil, most of them go straight through the foil because A. Alpha particles are positively charged, B. The mass of an alpha particle is more than the mass of an electron, most of the part of an atom is empty space, D. Alpha particles move with high velocity. So the correct answer is most of the part of an atom is empty space. So the answer is C. In case of Rutherford's experiment of alpha particles, this is the nucleus which is positive. You have seen that a few alpha particles got reflected because of the positive charge of the nucleus, and most of the alpha particles pass through the atom and some got negotiated like this. So electrons are revolving in orbits and most of the part is empty or empty space. That's why the alpha particles are able to get through. So here the correct answer is C. Most of the part of an atom is empty space. Fifth, an electron is moving along positive x-axis in a magnetic field which is parallel to the positive y-axis. In what direction will the magnetic force be acting on the electron? A. Along negative x-axis, B. Along z-axis, negative z-axis, C. Along positive z-axis, and D. Along negative y-axis. Here we have three-dimensional coordinate system. This is the x-axis positive, this is y-axis positive, this is z-axis positive. So here it will be negative x, this will be negative y, and into the board, that is the paper, that is negative z. So as per the question, electron is moving along the positive x-axis. So electron is moving this way, that means we can consider that the charge, that is the positive charge, is moving in this direction, that means the velocity is in this direction, and the magnetic field is along y-axis. So the force, magnetic force, is always equals to moving on a charge placed in moving in a uniform magnetic field is given by V cross B. F is equal to Q V cross B. So this force is always perpendicular to the magnetic field as well as the velocity, because it is a cross product. And the direction of this F is where you just say see V cross B. So according to right hand screw rule or cork screw rule, if we just rotate this way, so then the screw will advance into the paper, into the board. So the direction is negative z axis. We can also find out the direction of the magnetic force on the charge with the help of Fleming left hand rule. So this is the magnetic field, this is the direction of the positive charge velocity, that means this is the current. So according to Fleming left hand rule, the thumb will indicate the direction of the force. That means this way into the paper, into the board. So it is the negative z axis again. This is the magnetic field, this is the current. So the thumb is indicating into the board, that is negative z axis. So the correct option is B. Sixth, the relative magnetic permeability of a substance X is slightly less than unity and that of substance Y is slightly more than unity, then A part, X is paramagnetic, Y is ferromagnetic. B, X is diamagnetic and Y is ferromagnetic. C, X and Y both are paramagnetic. D, X is diamagnetic and Y is paramagnetic. Here we have X substance relative permeability less than 1 and Y substance relative permeability slightly greater than 1. We know that the diamagnetic materials have relative permeability less than 1 and susceptibility negative. Paramagnetic substances have relativity slightly more than 1 and susceptibility positive, and ferromagnetic have relative permeability more than 1 but its large value. So X is diamagnetic and Y is paramagnetic. So the correct option is D, X diamagnetic and Y paramagnetic. So D is the correct option.